In this lesson, we want to look at a couple of different concepts. One is where we're going to evaluate uh, the sum of two angles using our sine of the sum of two angles or cosine of the sum or difference of angles, along with our idea of arc functions that we covered in a previous lesson. We're also going to look at some formulas for product to sum and sum to product, which help us evaluate. So let's start out where we've got an expression. We want to take the sine of the arcsine of 3/5 plus the arctangent of 2. Now, if you remember from a previous section, what we had when we used the arctangent, our idea behind this was that this was the same as saying, well, the sine of some angle, we'll just call it A, equals 3/5. Remember when we were doing arctangent or arcsine or inverse sine, we're looking for an angle. We're trying to find what angle has a sine of 3/5. And here we're looking for what angle has a tangent of 2. And so since it's a different angle, we'll call it B. And that's going to equal 2. So what we're actually trying to find here is the sine of A plus B. Whenever you deal with an inverse function or an arc function, you're looking for an angle. And so we're wanting the sine of A plus B. Well, we know from our sum that that's the same as the sine of the first, cosine of the second, plus cosine of the first, sine of the second. And we know from here that we can draw triangles. So if this is angle A, then the sine of A would be 3/5, and our other side would be 4. Here, the tangent of B well, the tangent is the opposite over the adjacent, and so our hypotenuse would be 1 squared plus 2 squared, so it would be the square root of 5. Now, we also, when we dealt with our arc functions, if you remember when it was positive, we gave it back in the first quadrant, and if it was negative, we had specific quadrants that we gave it in. So since these are positive, we're going to be in quadrant 1. And as we go through and we add these up. So now we can find out, well, the sine of A would be 3/5. The cosine of B would be 1 over the square root of 5, or I'm going to go ahead and rationalize that, and that would be the square root of 5 over 5. Plus the cosine of A is 4/5. And the sine of B is 2 over the square root of 5, or rationalize 2 square roots of 5 over 5. So as we multiply, we have 3 square roots of 5 over 25 plus 8 square roots of 5 over 25. So we can write all of that over 25, which gives us 11 square roots of 5 over 25. And it works out very nicely as we go through and do this, but we're dealing with finding the sine of arcsines, but arcsines are simply angles, and so we're finding the sines of the angles. Okay, let's look at another one, and in this one we may use a double angle identity. We might want the sine of 2, and I'm going to use the other notation that we have, inverse tangent of 3/4. Remember, our inverse tangent and arctangent are the same thing. So again, this part, when it's dealing with this is simply an angle. Another way we could have that written is the tangent of some angle is equal to 3/4. We're trying to find out what that angle is. Remember, the way that we would write that then is, well, the inverse tangent of 3/4 equals A. So this is the same then as the sine of 2A, which we know is 2 sine A cosine A. So this would be 2. Now we're going to need our triangle. If this is A, then the tangent was 3/4, so this is a 3/4/5 triangle. So the sine of A is 3/5, and the cosine of A is 4/5. So we have 2 times 3 is 6 times 4 is 24 25ths. So again, this is just incorporating our functions for sums of angles or for double angles and using the idea of your arc functions. Now, we could go through and actually come up with some equivalent expressions. Let's say that we have the tangent of the inverse cosine x. And we want to come up with a value for this. Well, this again is an angle. What we're saying here is the cosine of some angle is equal to x. And so we're wanting then the tangent of that angle. Well, if we draw our triangle, and this is angle A, the cosine is x, so that would be x over 1. If we want to find our other side, which we'll call y, well, using our Pythagorean theorem, then x squared plus y squared equals 1. So y squared equals 1 minus x squared, and y would equal plus or minus the square root of 1 minus x squared. And we're going to take the principal root. So the tangent now is the opposite over the adjacent. So the tangent of that angle would be the square root of 1 minus x squared over x. And we can deal then with our arc functions. Okay, the other thing that we want to look at and spend a little bit more time in this section is working with what we have some formulas that help us take an expression that's written in a different form and possibly put it in a form that we can work with. And we have some formulas that we're going to have. We have our sum to product formulas. And our sum to product formulas are where we're taking a sum, like the sine of an angle plus the sine of an angle, different angle. And this is equal to 2 times the sine of the sums of those angles divided by 2 times the cosine of the difference of those angles divided by 2. We're not going to go into where these formulas come from. But we have the sum of two angles, the sine of A minus the sine of B, and what's that equals to? The cosine of A plus the cosine of B, the cosine of A minus the cosine of B. These are called our sum to products. If we have the sum of the functions of two angles, and we need it to be written as a product, then this is what we can do. We also have what we call our product to sum formulas. And that's where you're starting with a product, the sine of A times the cosine of B, and you're changing it back to the sums of two angles. The cosine of A sine of B, cosine of A times the cosine of B, and the sine of A times the sine of B. And so we're going to look at how we can use these to do some simplification. Let's start with this one. Ten times the sine of 5x sine of 3x. Now, we want to change this to a different form that where we can write it as a sum. This is written as a product. It's sine times sine. We want to write it back as a sum and maybe be in a little simpler form. So if you notice, it was a sine times a sine. So we're going to use this formula right here, sine A times sine B, and that's equal to 1/2 cosine A minus B minus the cosine of A plus B. We have a sine times a sine. Okay, we're looking at a sine times sine. So we have sine A, sine B. So this is the formula that we're going to be using for that problem. So let's go back and then say that this is equal to 10 times, okay, it was 1/2 the cosine of A minus B, so that would be 5x minus 3x, plus the cosine of A plus B, which would be 5x plus 3x. Okay, now we've got some multiplication out here that's outside the parentheses. We know we're to do the parentheses, but this is outside, so 10 times 1/2 would be 5. And then what we have is the cosine, 5x minus 3x is 2x. 5x plus 3x is 8x. And then if we wanted to distribute the 5, we can to each term, so we would have 5 cosine 2x plus 5 cosine 8x. And so we've taken a product and we've rewritten it as a sum. And it might be that we need that to do that to simplify some problems. Let's look at another one where we go from a product to a sum. Let's say that we have the cosine of 3 pi times the sine of pi. Here we've got some actual angles. Well, if we look at our identities, we had a cosine times a sine. So here we have cosine A, sine B, and it's 1/2 the sine of the sum of the angles minus the sine of the difference of the angles. So if we put that in, then this is going to equal 1/2 the sine of the sums of the angles, so 3 pi plus pi, minus the sine of the difference of the angles, so 3 pi minus pi. That equals 1/2 the sine of 4 pi minus the sine of 2 pi. Now, since we have an angle, we can actually evaluate this. 4 pi. Okay, if we start at 0 and we go all the way around, that's 2 pi. So if we go all the way around again, that would be 4 pi. And so it's the same as the sine of 0, which is 0. Now the sine of 2 pi is 0. So we have 1/2 times 0, which is 0. So by putting this in, we actually can evaluate it. Let's look at another one where we're going from a product to a sum. Say we've got the cosine of 60 times the cosine of 30. And we want to write this as a sum. Now, we can evaluate it as it is. We know the cosine of 60 is 1/2. The cosine of 30 square root of 3 over 2. So if we multiply that, we get the square root of 3 over 4. But we're practicing going from a product to a sum. So even though we can evaluate it fairly easily, we're going to use our product to a sum. So we want a cosine times a cosine. So this is the one that we would be using. So this would equal 1/2 times the cosine of A plus B, so 60 plus 30, plus the cosine of A minus B, 60 minus 30. So that's going to be 1/2 times the cosine of 90 plus the cosine of 30, which is 1/2. Now, the cosine of 90 is 0. The cosine of 30 is square root of 3 over 2. So we have 1/2 times the square root of 3 over 2, which is the square root of 3 over 4. And as you see, we could have gotten that much easier just doing our values, but we can do this with other angles that we may not know what those values are. And so it gets it in a little simpler form. But we practiced it on something that we could then easily see what our answer was so that we could check it. Okay, let's look at doing some sums to products. And so let's take the sine of 75 minus the sine of 15. Here's one that we don't know what that answer is. We know that we could use maybe some our sum formulas and our different formulas and get that. But we also have a formula for going from a difference to a product. So that would be what we have here is sine A minus sine B. So we're going to use this formula in this case. So this is equal to 2 times the cosine. Now, it was A plus B over 2. It's our angles divided by 2. Then the sine of A minus B, so 75 minus 15 over 2. Well, this is 2 times the cosine. 75 plus 15 is 90, and 90 divided by 2 is 45. 75 minus 15 is 60. 60 divided by 2 is 30. So we have 2 square roots of 2 over 2 times the sine of 30 is 1/2, and we end up with the square root of 2 over 2. And that was a lot easier than doing our sum, the sine of the sum of angles minus the sine of the difference of angles. We were able to put it into our formula. Let's look at one more like that. It's the cosine of pi over 12 plus the cosine of 7 pi over 12. Now the whole process in this is finding the formula that matches. We had a cosine plus a cosine. So it's going to be 2 cosine the sum divided by 2, cosine the difference divided by 2. So this is going to equal 2 times the cosine of half the sum of the angles. Well, that's going to be pi over 12 plus 7 pi over 12 divided by 2, then the cosine of the difference. So pi over 12 minus 7 pi over 12 divided by 2. Okay, what we have then is the cosine, that's 8 pi over 12, which can reduce, but let's just go ahead and do it this way. 8 pi over 12, then divided by 2 is the same as times 1/2. And the cosine of negative 6 pi over 12 divided by 2 is the same as times 1/2. So we have 2 cosine, okay, 2 goes into 8 4 times. So we have 4/12, which reduces to 1/3, which gives us pi over 3. Then the cosine, 2 goes into 6 3 times. We have 3/12, which reduces to 1/4, and it's a negative. So we have 2 cosine. Now, this is a 60, cosine of 60. Well, let's just leave it since I've already written cosine. I wanted to get to this part. Remember, we have our odd-even identities, and we have that the cosine of a negative angle is equal to the cosine of that angle. So we can also write this as the cosine of pi over 4. Remember when we talked about this, it meant that we didn't have to deal anymore with negative angles. We can, but we have our odd-even identities, which help us to change that then to a positive angle. So this is 60, cosine of 60 is 1/2, cosine of 45, square root of 2 over 2. And you might say, well, what if I forgot about my odd even? Well, all that did was put it into the fourth quadrant. The reference angle is still pi over 4, and in the fourth quadrant, the cosine's positive. So 2 times 1/2 times square root of 2 over 2 is square root of 2 over 2. 2 times 1/2 is 1. So we were able to simplify that. So our changing from sums to products and products to sum is simply a way of simplifying your angles. And the main thing you have to do on these is find the formula to use. And so you have to look to see, well, what do I have? And then how do I rewrite that using those angles so that I've changed from a sum to a product or a product to a sum. Okay, now we can also simplify some of our identities, and using this we can take some problems and maybe make them turn out to be a little bit easier. Let's take this identity. The negative tangent of 4x is equal to the cosine of 3x minus the cosine of 5x over the sine of 3x minus the sine of 5x. Now, without our formulas that we're going to use, this might be fairly difficult because we're dealing with multiple angles. But if we notice in our numerator, we have a cosine of an angle minus a cosine of an angle. So we have a formula, cosine of an angle minus the cosine of the angle is -2 sine the sum of the angles divided by 2 times the sine of the difference of the angles divided by 2. So if we plug that back in, then what we have in the numerator is -2 times the sine of the sums of the angles, so 3x plus 5x over 2 times the sine of the difference of the angles, 3x minus 5x over 2. Okay, in our denominator, we have a sine minus a sine. So we would use our sine minus a sine to cosine sine. So our denominator is going to be 2 cosine of 3x plus 5x over 2 sine 3x minus 5x over 2. Now if we go through and simplify, we have negative 2 times the sine of 8x divided by 2 would be 4x. Here 3x minus 5x would be negative 2x divided by 2, so that's negative x. Over 2 cosine 3x plus 5x is 8x divided by 2 is 4x. Sine 3x minus 5x is negative 2x divided by 2 is negative x. Now, here we can go through and our 2's cancel. Our sine negative x cancels. We can cancel now because it's all multiplication. So what we're left with is negative sine of 4x over cosine. Well, sine over cosine is tangent 4x. And that's what we were looking for. So we just found our values. And what it made it nice was by having a product, then we could cancel. You remember you can only cancel factors. And we didn't have to use it here, but remember from your odd angle identities, the sine of negative theta is equal to the opposite of the sine of positive theta. We just had dealt with the cosine, so I wanted to go through and remind you of that. So we have, we can deal with our arc functions, and then we can deal with our sum to product formulas and product to sum formulas, which help us change the form at times and change then the process of whether we're adding angles or if we're subtracting them.